Hello Pre-Calc students, welcome to the 10.1.3 video, How Can I Use Vectors? So today we are going to do word problems using vectors. We're going to solve real-world examples. So let's get started. It says the velocity of a moving object is a vector because velocity has both magnitude and direction. The magnitude of velocity is speed. Guys, underline that. The magnitude of velocity is speed. Recall that bearing is the angle that the line of travel makes with due north in a clockwise direction. Clockwise direction. Okay, and bearing is the same thing as heading. So we've got a lot of new terms that you need to be comfortable with. Bearing and heading mean the same thing. The next bullet says the angle used in the vector v, represented by xy, is made up from the magnitude of v times the cosine is going to give you your x direction, and the magnitude of the vector times the sine of the angle will give you your y direction. And this is not a bearing angle, but that gives you the angle in the standard position. Remember that angle in the standard position always starts on the positive x-axis. So this means that an angle adjustment must be made when giving a bearing angle and calculating the magnitude and direction of the vector represented in the problem. Let's take a look at this first piece. It says a bearing of 165 degrees. Let's just draw that. What does that mean? A bearing of 165 degrees. Well, we're going to start from due north and rotate clockwise. This is 90. All the way down would be 180. And so we're landing somewhere right about here, 165, about 15 degrees before 180. So this is a 165 degree bearing. And how will we convert that to a standard angle? So let's put this over here. And I said that it's 15 degrees away from 180 degrees bearing wise. So we are going to look at starting our standard position, which is positive x, and rotating this way. Well, we know that this is 270, so 270 plus 15 is 285 degrees. So changing a bearing angle measure to an angle of standard position, you just need to think about where you're at, how far are you away from the next quadrantal angle. Okay, so let's take a look at some examples here. Number one, an airplane is flying at a bearing of 335 at 530 miles per hour. We're going to express the airplane's velocity in the following ways. So first of all, we're going to draw it with an arrow, then we're going to find the vector component form, and then we're going to describe what's happening. So let's draw our vector. Whoops. And they said that it's a bearing of 135, so I know I'm starting, or excuse me, 335. So I'm starting in the positive y-axis, in other words, due north, and I'm going all the way around. So this is 270 plus 65, so this is 270 plus 65 degrees more would get us our 335. So this is a 335 bearing, 335 degree measure in bearings. So I need to figure out my rotation from the positive x-axis to where I just landed in my bearings. Well, if that's 65 degrees, 90 minus 65 is 25. So 90 plus 25 is going to be 115 degrees. So my standard position angle is 115-degree angle. Part B asks us to express the airplane's velocity as a vector in component form. So let's recall that we need to do the magnitude times cosine is going to give us our x direction. The magnitude times the sine is going to give us our y direction. Okay, and so magnitude, I believe I said it earlier, but maybe I didn't. Magnitude is speed when we're talking about velocity and vectors. You know what, let's write down two things. For velocity, which is our vector, two things. We have magnitude and direction, right? So here's our magnitude. Direction is your angle measure. Okay, this is kind of key to what we're doing, so please make sure that you jot that down. So I need the magnitude, which is the speed, which is 530 miles per hour, and times cosine of my angle measure, which we found to be 115 degrees. And then my y direction is going to be 530 times the sine of 115 degrees. Okay, so using your calculator, making sure that you are in degree mode, we would crunch that out and we would find that the 530 times cosine of 115 is negative 223.988, and the y value is 480.343. So what does this mean? Describe the components and what they tell you about the airplane's location. So we've got two parts, two components. We have the x direction, which we're calling the horizontal component. So it's negative 223.988 is the horizontal component. And I'm just going to put in parentheses our x direction. Okay, which means it's traveling west. It's traveling west. Okay, and 480.343 is the vertical component. And that means that it's traveling north. How do I know that it's traveling west and north? Okay, well, if my horizontal component is negative, horizontal is going from my, think of it as a number line. These are the positives, these are the negatives in the horizontal direction. In the vertical component, think of your up, down. This is positive, this is negative. So if my vertical component was negative, it would mean that it was traveling south. Okay, let's put it all together. Putting them together, that means that the plane is going to travel just west of north. Let's go back to part A, where it asked us to represent this in a picture or with arrows. Take a look at my direction. We are going mostly north. mostly north, with just a little bit, 25 degrees west. So that's why we say just west of north. Okay, let's try another problem. Number 2, it says an airplane is flying on a compass heading, in other words, a bearing. Remember we talked about heading and bearing mean the same thing, of 170 degrees at 460 miles an hour. A wind is blowing with a bearing of 200 degrees at 80 miles an hour. So we need to find the component form of the velocity of the plane. So we're going to break this apart to two pieces. First of all, finding the velocity of the plane, then the velocity of the wind, and then we'll put it together. Okay? So part A, guys, this is a huge problem. So this is definitely a quiz question. All right, so let's make sure that you can wrap your heads around it. Looking for our component form of velocity, we first need to find out what is the standard angle measure when we have 170 degrees of a bearing of 170 degrees. So starting with due north, and we're doing 170, so this is 90. That's 180, so I know that I am 10 degrees shy of 180. Okay, and so if I'm looking for my standard angle, I start positive x-axis and we rotate counterclockwise. So this is 270 plus 10 degrees gets me my standard angle of 280 degrees. And the magnitude, in other words, the speed, is 460 miles per hour. Okay, so coming up with our component form, it's going to be 460 cosine of 280 and 460 sine of 280. Crunching that in your calculator, it's going to be 79.878 and negative 453.012. Okay, so just looking at my component form of the airplane, we are going to be just east of the southern direction. Guys, I don't know if you remember, but never eat, soggy waffles. Let me put that in a different color. North, east, west, never eat soggy waffles, SW. Okay. So let's take a look at the component form of the velocity of the wind. So the wind is blowing at a bearing of 200 degrees and 80 miles an hour. Okay, so 200, bearing of 200, starting due north, 180 plus 20 more gets me my bearing of 200. And so let's come up with our standard angle measure. Starting on my positive x-axis, this is 180 plus 70 more. So 180 plus 70 gets me my standard of 250. So coming up with my component form for the wind, it's going to be 80 miles an hour times the cosine of 250 and 80 sine of 250, which calculates to be negative 27.362 and negative 75, whoops, that's a 7, 75.175. Moving on to part C, it says find the actual ground speed and direction of the airplane. Remember that in velocity, magnitude is speed. Okay, and so we have to find three things. We need to find the speed, the direction, and the bearing. Okay, so we're going to start out by finding the resulting vector, and the resulting vector of the plane, you're going to think it's the plane component plus the wind component, because the wind is working with or against the plane depending on the direction of the flight. So, excuse me, we are going to find first of all the resultant vector, and then we're going to find the resultant speed, and then we will find the direction. Okay, so let's start with our resultant vector. Recall that we're just adding the component forms of the plane with the wind. So pause the video and write down the two components that you would be adding. This just goes back to our vector addition that we've already practiced. Okay, so looking at the plane component and the wind component, adding like terms, in other words, I'm going to add my two x components together, I get 52.516. Adding my y components, I get negative 528.187. So next piece is speed, and speed is just the magnitude. Remember that we're looking for let's just give this a quick sketch. Let's say it's somewhere down here. I am looking for what is the length of that vector. And so to do that, I'm just going to do Pythagorean theorem, right? How far in the x direction do we go? How far in the y direction do we go? Well, that is what we just calculated in the resulting vector. So I'm going to take and do Pythagorean's theorem, and I'm going to just jump to the square root part of 52.516, 516 squared plus negative 528.187 squared. And crunching that out in my calculator, we get 530.791. Okay, so that's my resultant speed. I can throw that in here right away. So 530.791, and that's miles per hour. Okay, and then our direction. So remember that the direction is found by taking the angle measure. So going back to my picture here, here's my theta that I'm looking for. Well, if I know that this is 52 and this is negative 528-ish, I want to find my direction, which is just going to be tangent inverse of y over x. Tangent is y over x, opposite over adjacent. So let's crunch our numbers in there. Okay, we are going to do tangent inverse of negative 528.187 over 52.516. Okay, take a minute to crunch that out. Let me move my paper up. We're going to get the angle measure is approximately negative 84.322. Negative 84.322, that is our direction. So let's give it a quick sketch. But that's the direction in the standard angle measure. So negative 84 I'm rotating backwards, 84 degrees, which is going to be really close to 270. So this is negative 84.322. And we always want to express our answer in the positive angle measure. So I need to figure out, well, what is this? Well, putting them together, it would be 360, so we're just going to do 360 minus 84.322. And we end up with what? 275.678. Okay, so my direction is 275.678. Okay, and then they ask us for the bearing. Well, let's just go back to the picture that we've got here. Bearing now is going to be from due north, and I want to rotate clockwise. Well, I already know that this is 84.322, so I just need to add to that the top quadrant, which is 90. Okay, and so I'm going to get 174.322. So the bearing is 174.322. Okay, guys, that's kind of a lot. I need to make sure that you understand what we did here. So going back to part A, we found the component form of the plane, the velocity of the plane. Then we found the component form of the velocity of the wind. The resultant vector means put it together. How is that wind acting on the plane's velocity? Excuse me. And then from there, we can find the speed. So we use the resultant vector. This is huge. You have to be able to come up with the resultant vector. Whoops, go away. In order to find both the speed and the direction. Okay, so let's try another problem. All right, number 3 is your homework tonight. It is exactly like the problem we just did. So I'm going to let you follow the model of what we just did to do number 3. We are going to jump to number 4. It says a sailboat is moving across an inlet which has a current from 2 rivers. The current from River A is pushing the boat at a rate of 20 miles an hour with a bearing of 40. The current from River B is pushing the boat at a rate of 10 miles an hour with a bearing of 340. In addition, there is a 7 mile an hour wind that is blowing the boat directly east. Find the actual speed and the bearing of the boat. So this one is just like the last problem that we did, but instead of just having a wind, we also have a River A vector and a River B vector. Okay? Let's get ourselves set up here. So I'm going to start by drawing a picture of River A. We need River A, we need River B, and then we'll come up with our actual. So River A, it says that, where am I? River A, pushing the boat at 20 miles an hour at a bearing of 40. Okay, so the bearing of 40 is here. Bearing of 40. And we need to come up with what is the standard angle measure. Well, the standard angle measure is just going to be rotating in this direction, and that will be 50 degrees. Okay, so River A vector. So we're going to take our 20 cosine of 50 and 20 sine of 50. And that gets us, actually put that away, crunching that in my calculator, we get 12.856 and 15.321. Okay, well that's River A. I'm going to grab a different color and do river B. So first of all, river B, oops, has a 10 mile an hour with a bearing of 340. So 340 from my positive Y all the way around. So here's 340, which means this is 60 up here. Grab my red. This is 60. And so my angle from the standard position is going to be 90 plus 60, which is 150. Oh, excuse me, 110 degrees. Okay, so river B vector component is going to be 10 degrees cosine of 110 and 10 sine 110, which gets us negative 3.420 and 9.397. Okay, so we have calculated river B and we've calculated river A. The next piece that we need to calculate is the wind. All right, so grabbing a different color. The wind is 7 miles an hour and directly east. Okay, well that's a new piece. So 70 miles an hour directly east. Let's get that picture. So this is the wind. Directly east means right there. So what is that angle measure in the standard angle? 0 degrees. So the wind you're going to have 7 cosine of 0 and 7 sine 0. Well, cosine of 0 is 1. Don't even need our calculators for this. 1 times 7 is 7. Sine of 0 is 0. 0 times 7 is 0. So the wind vector is 7, 0. All right, so now we need to do those pieces where we put it all together. So just like we did on that last problem, we need to find our resultant vector, our resultant speed, the direction, and the bearing, okay? So the resultant vector, I want you to pause the video because I want you to find the resultant vector by yourself, which is just your vector addition of river A plus river B plus the wind. And then you're going to find your resultant speed, which is doing our Pythagorean theorem using the x component and the y component of our resultant vector. And then we will reconvene. Okay, let's talk about it. So again, our resultant vector comes from adding the x components. So I highlighted them to make it a little easier for you to see. We're going to add those up and we get 16.436. And then I add my y component to get 24.718. To find my resultant speed, that's just doing our Pythagorean theorem with the x component and the y component of the resultant vector. Guys, I know that this is a lot of terminology, it's a lot of new words, but just try to wrap your heads around where are these things coming from, okay? Finally, we need to find our direction, and so the direction comes from our tangent, because remember that we are doing, give me a second, direction is the tangent of that angle measure, so theta is going to be tangent inverse of 24.718 over 16.436. which is approximately 56.378. Remember that that is our standard angle measure. This is the standard. Direction always gives us the standard. Excuse me, I should say the tangent always gives us the standard angle measure. So we need to change that from the standard angle measure to bearings. Well, it's always easier to work off of a picture. So I drew the angle from the standard angle position, which is 56.375, and bearings starts due north, and it's going to rotate clockwise. And so I'm just going to do 90 minus, let me put it up here, 90 minus 56.378, which calculates to be 33.622 degrees. Okay, so we have found, it says find the actual speed and the bearing of the boat. So our actual speed is 29.684. We found that right here. And the bearing is 33.622. Okay, last problem. Number 5. A force of 50 pounds acts on an object at an angle of 45 degrees. A second force of 75 pounds acts on the object at an angle of negative 30 degrees. Find the magnitude and the direction of the combined force. Okay, so people, once we get the idea, the process is the same. We're going to find the vector for the first force, the vector for the second force, and then the resulting vector force. Resulting means we're adding those together. We need to be careful on this one because it asks us, or it gives us 50 pounds at an angle of 45. It doesn't say bearing or heading. So this already is the standard angle. Okay, and so 45 degrees for my first force. So let's get that one set up. First force vector. So that's going to be 50 cosine 45 and 50 sine 45. Now I know that the sine of 45 and the cosine of 45 is 2 root 2, but I still need to multiply that by 50, and so I do know that the two of them will be the same, and they are both 35.355. Okay, and then let's go to our second force. Well, the second force has an angle measure of negative 30. So here's my negative 30, and again, it didn't say bearing or heading, so it's just our standard angle measure. So I can crunch that out right away. Second force, vector, okay, so check your answer. The second force vector, you're doing 75 cosine of negative 30 and 75 sine of negative 30. Now you could have done a positive 330. That would have been the same. We'd get the same answer. Let me just stick that in there. Could do a positive 330. Or that negative 30. So we get 64.925 and negative 37.5. So let's find the resultant vector by adding them together. So that'll be found by adding our x components plus our y components. Okay, so let's just add x's together and then y's together, and so we end up with a resultant component of, which is our resultant force, 100.307 and negative 2.145. So how do I find the magnitude? Same way we found the magnitude before, guys. It's just going to be using Pythagorean theorem. And so it's going to be magnitude, I'm going to abbreviate mag, square root of 100.307 squared plus negative 2.145 quantity squared. Crunch that into your calculator, and we get approximately 100.330 miles per hour. And then our direction, remember to find our direction, we're going to do the tangent inverse. Direction. Theta is going to be found by taking our tangent inverse of the y over the x, negative 2.145 over 100.307. Crunching that out, you're going to end up with a negative angle measure of 1.225. And so we want to find the positive. Well, negative 1.225, let's just get ourselves a quick picture here, is going to be at just barely below. Okay, so this is a negative 1.225. How do I find the positive angle rotation? Well, guys, we're negative, or excuse me, we're 1.225 away from being 360. So you're going to do 360 minus 1.225 to get 358.775 degrees. Okay, this is not easy material if you don't practice it. You really need to just go through the motions and get the ideas down. All right, have a great day.